Okay, sorry about that if we lost you. And I don't know where you got lost because I haven't looked at the replay, but I'm just going to continue where I am and hopefully you'll be able to pick it up. So think hard. Bye. Here we go. Okay, we were on example 1, page 415. And we just got finished with the E part, the sine of, the inverse sine of the sine of 5 pi 6 turned out to be just pi 6, since pi 6 belongs to 5 pi 6 in the first quadrant. Okay, so let's move on and see what we're in for with the others. It's not, I mean, if you understood this one, we went kind of slow, understood this one sort of, it will become more solidified as an idea as we move on. Okay, so example 2 says, use a calculator. In radian mode, we evaluate these inverse sine values. That's a lot easier. You just plug it in, and it will make sure you land in the proper quadrant because the calculator is only got it defined as a quadrant. So, and we are in radian mode, so let's do this. We take the inverse sine. The inverse sine of negative 0.81. Then we get, that's what they got, negative 0.944. Your calculator knows these rules. Okay? And do the other one, you enter it all together just like it is. You do the inverse sine, parentheses, sorry, I got a parentheses, so type of sine, parentheses, well, it's got its own, 3.495. Close it, close the big one, and you get what they got. They get 1.539. So if you're adept at entering things in your calculator with parentheses and stuff, you should be able to evaluate the back.
What is it from degree mode?
What? It's a degree mode.
Yeah, but what happens if you put it in degree
It's
mode?
in degree mode, then you want your angle at the end of B. But what will happen in A is that when instead of giving you 0.94 radians, it'll give you something like 52 degrees. 0.94 radians, a whole radian is about 57.3. So you would have gotten about 52 degrees. Negative 52 degrees, I would say, negative 52. And to do the other one, if you'd have done that in degrees, then the 3.49 pi would have, the two would not reconcile at all. Okay. So on the next page, page 416, they talk to you about the same diagram that I've already erased up here when we talked about the serpentine form of cosine and how we restrict it. So let's just jump right over to, they did that with tangent too. The cosine discussions in the middle of 416, the tangent discussions are out on page 417. Now we're going to just dive in and see if we can make them apply. Example 3 says, find the exact value of the expression without a calculator. Okay. So it's the inverse cosine of negative root 2 over 2. Now, keep in mind where inverse cosine is defined. Have you got in your head where that's defined on the unit circle? Cosine? Inverse cosine, I mean? Which quadrants? First and second. Which one shall we look in for this answer? Second, because cosine has its negative values in the second quadrant. The inverse cosine does.
Is that coming from the all students take calculus?
Yep.
Okay.
Well, sort of. Because cosine is only defined here and here. Cosine will be all your positive cosines. Here, you're looking for these to be positive. If you've got a cosine of an inverse cosine of a negative, you got to look in this quadrant because of the all students take calculus. Yes, but we're only defined from here to here. So if you're doing an inverse cosine of a negative, you can only look in the second quadrant.
But isn't that S or something? Like we're about to see.
Yes, but we're talking cosine, so it's positive, negative, negative, positive for cosine.
Oh, yeah.
If we're talking only about cosine, that's the way it goes. And so we get all of our inverse cosine values in the first and second quadrant. Since they're all positive here and negative here, we cover the whole gamut in the first two quadrants.
Oh.
Revelation. Yes. Okay. Here we go, folks. So since inverse cosine is only defined in first and second quadrant, we look in the second since we're inverse cosine. We want to draw it. gonna be over here, and we've got to draw an angle such that the cosine of that angle is root 2 over 2, which means the reference angle is 45 degrees.
Okay.
So the question is, what is this angle? It's not this angle, it's this one, because we make our angles for cosine from first over to pi, and so it's this one will be 3 pi fourths.
Because it's 3/4 of pi.
Because this is pi fourths, and this is 4 pi fourths.
Okay.
So the angle we're looking for is the one opened up from here going into the second quadrant, 3 pi fourths. Because the reason why it's 3 pi fourths, well, it would work if it were just pi fourths too, but we're talking about the entire angle, and that 3 pi fourths is trapped in between 0 and pi. Okay. All right, so let's try the next one. Example 3, part B, inverse tangent of root 3. What?
That was the answer?
Okay.
3/4.
Yep.
Okay.
Next one says, without a calculator, find the inverse tangent of root 3, negative root 3. So think to yourself, where am I allowed to look? What? No. First and fourth. First will give you all the positives, fourth will give you all the negatives for tangent. It is true that tangent is positive in the first and third, but we're not looking for positives. We're looking for the entire range of values for tangent.
Could tangent be first and second?
Is this why it's
It
an
has to
odd
be first and
function?
third.
It could be first and second, but it's a very, very strange looking graph. We wanted it to be first and fourth because if you'll remember, the graph of inverse tangent looked like this, and it was nice and complete.
Yeah.
And it was between negative pi halves and pi halves. If we did first and fourth, we would have this piece of this and this piece of that one. First and second, you know what I mean?
Okay.
So we chose first and fourth so that we'd have a nice continuous piece of the inverse tangent graph. So what I'm asking is, inverse tangent is defined in first and fourth. Which one will we look in for this one? Fourth, because that's where the negative ones are.
Oh.
And what kind of a triangle do we have whose tangent is the big one, root 3?
30, 60,
But is it stand up or lay down?
way down.
Stand up. Because the angle's bigger. You get a bigger tangent, people. You get a bigger tangent when the angle's bigger. So we need the bigger angle of the two. That's crappy, but anyway. That reference angle is pi thirds. Since we can only go between negative pi halves and pi halves, we will call that angle, that direction, and the answer to this is negative pi thirds. And sure enough, negative pi thirds that we just said was the answer is between negative pi halves and pi halves.
Is the range for all of them negative pi halves and pi halves?
Only for tangent and sine. For cosine, it's 0 and pi.
Wait, so how did you find what negative square root of 3 was? Like we knew that it was in the bottom.
When I was talking to you about tangented angles, when you have a root 3 or either a root 3 or a root 3 over 3, it's going to belong, the tangent part of it's going to belong to a 30, 60, 90. Question is it laying down or is it standing up? Because this number here is bigger than root 3 over 3.
Okay.
It is the tangent of the bigger angle of the two, either pi thirds or pi sixths. The bigger result for tangent belongs to the bigger angle. So this is pi thirds, but it's negative.
Is the reason you're saying that tangent and sine are odd is because they go in the first and fourth quadrant? Is it have something?
Because their inverses do, yes. Well, that's hard. Here's why sine is odd, or since you asked the question, here is why sine is odd. Because it has origin symmetry. Here's why tangent is odd. Because it has origin symmetry. Here is why cosine is even. Because it has y-axis symmetry. That's an easier way to explain why it is what it is. Making this fit to the unit circle and talk about odd and even, that's a rough go. We're not doing that. Okay. All right. So that's the reason for that. We'll come back to that when it becomes really important, but it is because both sine and tangent are odd that they have the same range of values that they're stuck in between, first and fourth quadrant. All right. Let's do the third one. The inverse cosine of the cosine of negative 1.1. The inverse cosine of the cosine of, is it negative? Is it 1.1 or negative 1.1? Who wants what? Okay, guys, what do you suppose the cosine of negative 1.1 is? That is not a familiar angle. So we draw a picture. The cosine of negative 1.1 is, that's an angle, and so I'm going to open it up in the fourth quadrant. 1.1 radians is about to there.
Wait, isn't cosine in the first?
Cosine is in every quadrant. Inverse cosine, I'm not addressing.
Okay.
The cosine of this negative angle, this is an angle, and it's negative, it's opening up this way, and it's negative 1.1 radians, it's about that tall. So what is the cosine of that? And you're going, I don't know. I'm telling you, it is this. That's the cosine of negative 1.1, that length. Hang on. What is the inverse cosine? I mean, what I'm saying is, what angle do we know of whose cosine is this? And the answer is negative 1.1.
Oh, wait,
We've got a big problem. We've got a big problem because that is not the answer. I lied. This is not the answer. Because, listen, because it's in the third quadrant. I need my angle to be in one of these two quadrants. I'll show you how to reconcile that when we return tomorrow. I didn't get a chance to get it all done because you guys asked too many questions. We'll talk about this, come back to it. I'll remind you of everything and then we'll try to do that problem. Okay? Anyway, we've got a couple more examples to do and then assignment. I'll finish this in another one later. Oh, great. Look at what it was. Sorry, guys. Hopefully, here, I'll get out of the way. That's all the stuff we just did where you could only see half the board. Sorry, that's my fault. I don't know what I was doing. Anyway, there it is. We'll talk more tomorrow. Bye.